Okay, today we're going to look at cubic functions. So our learning intention is to understand what cubic functions are. We need to understand them algebraically as well as how to graph them as well, so graphically. So see, some of the success criteria is obviously we've got to need to know the general form of the cubic. We need to be able to translate the cubic around the Cartesian plane, know what a point of inflection is, and correctly find the equation of a cubic. Okay, so a cubic function has an equation where the highest power of x is 3, such as f of x equals kx cubed. So the k is obviously a constant, so we can have things like y equals 3x cubed, or y equals 2x cubed, or y equals a quarter x cubed. I'll do another fraction, or y equals an eighth x cube. Okay. Also, it's f of x where k is another constant, x minus b to the power 3 plus c. Something that would look like that would be obviously 2x minus 3 all cubed plus 1. Okay. Then we have f of x equals k, x minus a, x minus b, and x minus c. And as k, a, and b, and c are all constants. Okay. All right. So it's important to understand the general cubic and how it translates across or around the Cartesian plane. So the basic one we get is y equals x cubed. Okay, and if we did a table of values, you'd have when 1 and 1 cubed is 1, and 2, x is 2, y equals 8. Yep, and then we have negative 1, so negative 1, and negative 2, negative 8. Okay. Obviously, if we want to kind of broaden or widen the rate of how the curve goes up, we will put a coefficient of x cubed less than 1. So if we have, let's say, y equals kx cubed, if k is less than 1, the cubic will appear more wider. And if we have where k is greater than 1, the cubic will become more narrower. Yep. So you might get something that looks like that, and something that will look like that. Okay. So if I was to add a constant, and here I've called it d, I basically get my basic cubic and I translate it up the y-axis by 1 unit. Yeah, or by, sorry, d units. Yeah, so that plus d would translate the cubic up the y-axis by d units. And if obviously we subtracted d, it would translate it down. So this is y equals x cubed minus d. So minus a constant will translate the cubic, vertically down the y-axis. Okay. Now, if I wanted to translate this cubic across the Cartesian plane, I'll get a cubic such as this. I'd get x minus a, so that a would be positive. So a minus a would equal 0, which would be the cubic, and that's all cubed. Yeah. And alternatively, if I wanted to translate it to the left, I would get y equals x plus a all cubed. Okay, so when it's in the bracket, and we have x minus a, and it will translate to the right, a units, and when we have x plus a, it will translate it to the left, a units. Okay. A cubic can also have 3 roots. It can be written in this format. So we've got k, we've got x plus a, yeah, because I need a to be negative. We've got x minus b, and we'll have x minus c. And what that happens, it will cause, and because it's a positive k, it will cause the cubic to look like that. Yep. So when you have 3, obviously we could have x plus a, x minus b, which means that it will also go through 0. And I can also then obviously plus d if I wanted to shift it up the Cartesian plane. So a cubic can have up to 3 x-intercepts. Okay. And then obviously if I had that and plus the d, it will translate a cubic up x-axis. So one thing I want to also note, so we can have the mirror reflection like this. 1, 1. Yeah. So we could have this cubic, and when we have that, that's actually y equals negative x cubed. Yeah, so if it's negative, all these would flip around. So if I had y equals negative k a plus x plus a, x minus b, x minus c, it would go, because it's negative, it would go like that. Okay. Yeah. Okay. Some key points that we need to know. We need to know what a point of inflection is. So the point of inflection is the flat turning point of a cubic function. So we've got a cubic y equals x, kx cubed, and it's called a point of inflection. So where it turns, this point here is the point of inflection. It means that the concavity changes. So here we go. We have the y equals x cubed. So this function is always increasing. Yep, the y values are always getting bigger. But the concavity has changed. Here we have its concave down. So at this point, it's concave down. And as soon as we get to 0, 0, it changes its concavity and concaves up. So we've got y equals negative x cubed. Here our function is decreasing. So our y's are getting lower as we go further across x. So we're concaved up when we've got negative infinity to 0. And then all of a sudden from 0 to positive infinity, it's concave down. We've got y equals x minus b plus c. We've moved it, the point of inflection up c units. There we go. And here we've, same as the normal one, it's positive. The function's increasing. But between negative infinity and b, it's concave down. And between b and positive infinity, it's concaved up. And this point where it changes its concavity is called the point of inflection. Okay, so something to note, a cubic will always have one y-intercept. It will always cut the y-axis at one point. So even if we looked at here, somewhere, if I kept going further down, it would cut the y-intercept. And it can have up to 3 intercepts. Here we've only got 1, but we have seen examples where there's more than 1. So the general form of a cubic is f of x equals k x minus a, x minus b, x minus c. Note that they're all negatives. And when we have that, we'll have 3 intercepts. Alternatively, we have f of x equals k x cubed plus c when we know that we only have 1 intercept. So important to note. Okay, let's do some examples. We're going to sketch f of x. So g of x equals x cubed plus 2. So this is just the usual x cubic, x cubed. So it will look something like this. Yep, but I'm going to translate it up 2 units. So 1, 2. So this will be here. And all points will translate up 2 units. If I had negative 1, that'd be negative 1 plus 2 is 1. Yeah. So it would look, the cubic would look something like that. Okay. We now want to sketch h of x. We've got negative x, x plus 2, x minus 4. We're applying the null factor. The x-intercepts are going to occur when x equals 0, minus 2, because minus 2 plus 2 is 0, and positive 4. So we've got 0, minus 2, and positive 4. Okay. The y-intercept occurs when x equals 0. So we've got 0 times 0 times 0 would be 0. Okay. The cubic is negative. So automatically we have a function that will go like that. Okay. So we should have a function that will look like that. So y equals negative x, x plus 2, x minus 4. Okay. This example, we want to sketch x plus 2, x minus 3, x plus 6. So our x-intercepts are negative 2, positive 3, and negative 6. And our y-intercept when x equals 0, 0, so we've got 2 times negative 3 times 6. So is going to equal, so negative 6 times 6 is negative 36. Yep. That's just by setting x equals 0. Okay. It's a positive cubic. So it will go like that. Okay. Just a sketch. So we've got negative 2, or negative 6. Negative 6, negative 2, and 3. This is obviously not going to be the scale because I can't go to negative 36 down here, but it will look something like that. Okay. Okay. Example 2, we want to figure out the equation of a cubic. So cubic function is in the form of y equals k, x minus a, x minus b, x minus c. Find its equation if it has an x-intercept of 2, 3, negative 5, and passes through negative 2, negative 120. So the first thing to do is obviously write the general form. Then the next thing to do is plug in our x-intercepts. So x minus 2, x minus 3, and x minus negative 5 becomes k, x minus 2, x minus 3, x plus 5, as two negatives become a positive. Okay, now once we've got that form, we then substitute our known point. So here we write the general form. Sub in x-axes, x-intercepts. Okay, so we know that when x equals negative 2, y would equal negative 120. So we've got negative 120, k worth negative 2 minus 2, negative 2 minus 3, and negative 2 plus 5. So negative 2 minus negative 2 is negative 4, negative 2 minus 3 is negative 5, and then negative 2 plus 5 is 3. So we've got, that's positive 20 times 3 is 60, so we get 60k minus 120. 120 divided by 60 is negative 2. So we know the general formula, the equation of the cubic with x-intercepts of 2, 3, -5 and passes through -2, -120 is y equals k was -2, x minus 2, x minus 3, x plus 5. Okay, and that's all the examples. So looking back at our success criteria, we need to be able to know the general form of a cubic. So there's 2, that you'll get y equals kx cubed plus c, or you would get y equals k x minus a, x minus b, x minus c. Yeah, and you could have another constant if we were translating it, but that's the general equation. Know how to translate it across the Cartesian plane and what it looks like algebraically. Know what a point of inflection is. So the point of inflection is where it changes concavity. And know how to find the equation of a cubic given general information about it. So thank you.